Welcome to the Rich Report, a podcast with news and information on the world of cloud computing. Today, my guest is from Xeround. We have the CEO of the company. It's Razi Sharir. And Razi, welcome to the show today.
Hi, thank you for having us on the show. My pleasure. I'm looking forward to it.
Razi, I was looking at your slide deck here that we're going to go through, and Xeround is described as the cloud database. Can you tell us more about that?
Yeah, that's correct. So with your permission, just a couple words on slide number 2 on the deck, just to get us up and started on where we originally come from. So the company was founded way back in 2005, and was starting as a cloud database for actually telco productions, telco backward ops, and so on and so forth. And the good thing about it was designed from day one as a cloud ecosystem solution for a virtualized environment. So we went to the telco environment, and in fact, we run in a couple of telcos worldwide, serving tens of millions of users. So the pedigree and the core genes we come to equipped with for the cloud are actually telco certified. So it's a good place to get started with. So with this in mind and putting together the best of both worlds of our technical capability and a new offering that we went to the cloud with, I will jump in right into slide number 3, which describes exactly what is it that we're doing. So Surround is essentially a database as a service, and the emphasis is on the term service, because we are not a downloadable software and we're not an open source. We are a database as a service, which means that we would seamlessly support any existing MySQL application that are in a need of an elastic and an always-on availability. So in a sense, we replace the storage engine underneath the hood, so the front end remains MySQL. We just bring in our telco-certified, previously used type of technology, and we take it to the next step, and we now offer it in a cloud package, which makes it very straightforward, super simplistic, yet not giving away the very unique and competitive advantages of being able to elastically scale out unlimited and always be on for high availability purposes. So this kind of keeps us within the cloud, but with the previous pedigree qualifications. So what is it that we're actually chasing, and why did we move from the telecom arena into the cloud? So moving on to slide number 4, what are the issues that actually we're chasing? So we're seeing in the cloud today databases that are offered in various shapes, ways, and forms, but frankly, no one of the vendors out there is offering any SLA. So you could end up paying $10,000 a month for a database service and yet not get an SLA and no commitment on how available it would be or how scalable it would be, and so on and so forth. So that's a major drawback for somebody that came to the cloud anticipating a very high-end, super highly available and scalable environment. Second, not surprising, there's not an easy way to scale out in an elastic and a linear mode a database, and that actually applies not only to the cloud environment but to databases in general. But when you take a database and put it in a virtualized environment, especially if it wasn't designed for a virtualized environment, this becomes very tricky. In our case, it's slightly different because we were designed as a virtualized solution. The third issue that we see quite often is there's no multi-tenancy solution out there that can take care of an effective cost structure and an efficient operation model. What that means is that you could take potentially any MySQL database and install multiple instances of that on a single virtual machine. It won't be that effective cost-wise, let alone operational-wise, because then you would be running into multiple users sharing the same resources on the same machine. You could also install MySQL on a given large machine and have the users share the same MySQL, in which case you could potentially walk into a situation where users can see other users or can see what others are doing. So there's no multi-tenancy to sum it all up, real multi-tenancy that can be effectively and efficiently managed. And last but not least is the distribution nature of databases in the cloud. So today, pretty much databases would be to some extent very sticky to what you use. So if you log on to Amazon RDS and then you want to change your mind and move on to something else, it is not as straightforward as it may sound, and it may be very tedious to run, let alone to get a database replicated across multiple places, even in the same data center. Amazon would provide for some key capabilities, but when you want to take it to the next step, it doesn't seem to be as simple and straightforward as it may be. So let's see what are we doing in Surround in slide number 5, and how does our solution address all of these issues. So first and foremost, we went for a very simple, straightforward, service-oriented database. So in a sense, All you need to do is log on into our service, get a username and password. We would send you the IP address. You load your schema, and you can click run and be in the air with probably a matter of a few minutes. So that's very straightforward. Users that are on our system, and we had quite a few thousands of those by now, are extremely excited by the simplicity of the use of our system. So that's the core and straightforward path into our system. Then, since it's a service, we take the Disney Hakuna Matata approach, which says everything is built in. You don't need to worry about anything. You need to just focus on your application and let us run the database, which means that we have a built-in high availability, which is self-healing with zero configuration. You don't need to configure multiple replicas for read or write. You don't need to configure multiple locations. You don't need to configure actually anything. You could go in and manually muck with it if you really like that, but technically everything is handled automatically. So if one of the nodes goes down, the other node will see it and build a new replica out of it. We run out of the gate in multiple replicas in multiple locations, so there's nothing really to configure. We don't have an option to get a service which is not highly available. We are only a highly available solution. Then we have the on-demand scalability. So typically what people on the cloud see is that they get a mid-size container, and then at one point in time, traffic hits the site, and then throughput goes through the roof. The database would be the first component that would crash, and then it takes forever to bring it back alive, let alone to upgrade to a higher or larger container or VM, whichever way they use it. On our end, there's nothing to configure, nothing to actually do about it. We take care of that automatically behind the scene as well. We run on multiple virtual partitions, which is our core patents that are spread across multiple virtual machines, which are spread across multiple data centers. So there's nothing really to do for the users of the application in order to take care of any scalability issues. That's been taken care of automatically in the system, and we keep our cushioning and our system and alerts and monitoring at all points in time in all data centers or providers. So we keep track of what's going on, and we would take care of the scale demand as it goes on the fly. Then about distribution. When you log into a service, you select the service provider and the geographic location you wish. You click create, and you get a database created there. So you can choose today between Amazon in the US and Europe. You can choose between Rackspace in the US and soon in Europe, Heroku, we're backboning their service, and a bunch of others coming in. We'll talk about it later. So distribution-wise, you can get on our service and move between the providers as you wish at any point in time. There's no really stickiness in between the services. It all depends on where your service runs in terms of the application. So that's fairly straightforward. Last but not least would be the multi-tenancy approach that we bring to the market, which is mostly for the providers, not for the actual users, which means that we can provide anyone who's providing service in the cloud to use our service in a transparent or even branded mode, so that they can provide our service to their users in a very straight and simple way, which means that it's providing for a super efficient operation-wise, probably reducing the number of admins or attention span that is required. And then on the CapEx side, because they don't need to run any machines on their end, we take care of that automatically. So that's kind of sum it all up into what is the need and how do we address it. Moving on to slide number 6. That talks about a little bit about the technology. So again, Xeround was founded actually underneath the hood as a NoSQL database. So much like Hadoop, which is a distributed file system, Xeround is a distributed object system that gets balanced across multiple virtual partitions and virtual machines by a linear hash table. So we continuously rebalance the data and the databases across multiple hosts. So there's nothing actually that needs to be done by the actual end user, whilst on the front end, we keep the front end MySQL engine. So if you're running MySQL, essentially moving to our service requires no change other than the connection string. So this includes the virtualized database technology, the provisioning and management, the user service web portal, service web portal, and the operator web portal as well. So it's a full included, all-inclusive solution that has everything built in and is geared towards zero management and zero interaction. Everything is done automatically, but then again, it leaves the door wide open. So if you really like to mock up with anything manually or use any of the tools that you've used before on your MySQL databases, whether they were locally on your local machine or running somewhere else, you can still use them as is with no changes. And what this does provide is that, as I mentioned earlier, the high availability, the auto-scaling in and out, and the emphasis here on out, which is adding nodes on the fly without downtime, multiple nodes, and very simple to use. Seriously powerful, which means that you don't need to change anything, and that's the key thing to kind of put it all together. Moving on to slide number 7, and this is what makes Zound different, and this is the key differentiator from us and other services or other solutions out there. And what we're seeing here is a graph that represents, the yellow line represents kind of a step function that shows each and every one of the steps would represent a different size of a VM that you could hire today on Rackspace or Amazon, for that matter, RDS or whatever you. So if we start on the far left side of the graph where the axes connect and move on, so we see a machine, and then the traffic, which is the red line, would continuously go up or would pick up halfway through. And then as you need to address the traffic that goes up, at one point in time, the instance that you hired, whether you installed it yourself manually or you took it from RDS, would reach its peak, and then you need to scale out. Scale out meaning you need to move into a stronger machine or add nodes to the same machine, which typically means downtime. It's not mandatory in all cases, but it oftentimes gets translated to downtime, very tedious work on the DevOps side, updating the application, moving strings around, moving servers around, let alone backups and all of the things that are related to it. Whereas in Xeround, since our service is distributed and runs on multiple hosts at the same time, there's nothing to really configure. We would see the peak coming up and rebalance the peak across the multiple hosts that we are running continuously parallel. And each and every one of our hosts, as opposed to MySQL, does both read and write at the same time. So we're not constrained to a single master that does all of the writes, and that's why we can easily scale on the fly without actually downtime. Actually, it goes beyond that. We can even move databases from one host to another on the fly while they're running, and the users won't even know that we're moving them. That's what happened with Amazon in the U.S. a few months back when they were down for a month, and then in Europe when they were struck by, I believe, a thunderstorm or something, and they were shut down for almost 2 weeks. We moved our users while they were running, and some of them didn't even know we were moving them just to continue service. Moving to slide 8, a general architecture review before we dive into the details. So what we're seeing on the right side is the overall architecture. Down at the bottom is the virtualized data store. This is where the NoSQL engine comes into play and provides for the great capabilities. On top, we have the virtual SQL engine, which is the piece where we take the actual SQL statements coming in through the front end standard MySQL piece of software and distribute it and optimize on it that would fit our own virtualized data store. And then on top we have the virtualized load balancer, which is something we use to manage the load across multiple IPs, across multiple data centers. And this is in a sense connects to our DNS service and something that would be comparable to what Amazon calls the elastic IPs. So we can run agnostically on any cloud and still provide an elastic IP or a DNS service built in without actually having to reconfigure the app each time we see something needs to move around because a server is down or a server is up. This is totally transparent. Everything goes through API, so all of our system is fully API'd internally and externally, so we can provide the APIs through the resource manager either to the customers themselves that currently access the API through the web portal, and later on will have full access to the API, or to the database as a service operator that would use our service and offer it to their actual customers. Diving a little bit more into the architecture on the next slide, which is slide number 11, that talks about auto scaling. So what we're seeing here is the data store, multiple pieces of the data store, multiple pieces of the SQL engine, and multiple pieces of the load balancer. And the nice thing about it is that when you get a database running on our system, it's not a flat file that's kind of sits somewhere in a single storage like you would typically see in a MySQL environment, but rather the data is split into multiple bits and pieces that are spread across multiple components at every point in time. So we have more than 50% resiliency, so we can kill more than half of our running VMs, the core VMs, and still provide useful and powerful service to our users without them feeling that something is going wrong. So we run out of the gate with multiple replicas, and the way we scale is we can scale each and every one of the components on its own without having to scale or change anything on the other components, because as I mentioned earlier, each and every one of the nodes is read, write, like in a peer network that supports a distributed object model. So if we need to increase the data, we would throw in another data store module. If we need to decrease, we will remove it. If we're seeing more heavy-duty SQL processing, we can throw in on the fly additional SQL engine processing and then remove them when we don't need them anymore. or then we see lots of traffic coming in, which got nothing to do specifically with the way the statement works or the SQL statement works. We can add additional load balancers and handle the load in terms of traffic. So everything is pretty flexible. Everything is very dynamic, and everything is handled mostly automatically. In fact, our admins just make sure that the system doesn't, go out of whack. But we have seen it working in a telco environment with tens of millions of transactions. So we're seeing it working fairly efficiently in the cloud environment. We're continuously optimizing on multiple areas, but we're fairly happy and excited about this working so nicely in a cloud environment. So this is the auto scaling that would scale and stretch to fit the need, and again, it would be the scaling out as opposed to scaling up, which is no-brainer. Moving on to slide number 12, which talks about the high availability. So the patented virtual partitioning technology, which we have, assumes that what we take the data and we partition it into multiple partitions, and these particular partitions are spread across multiple hosts. So what we're seeing here specifically, we have a database with 4 virtual partitions, P1, 2, 3, and 4 in red on the top. And these partitions, as you can see, are spread across 3 different hosts, which would be the blue ones. So what essentially happens in this type of case is that if for some reason one of the hosts goes down, like we're seeing on the next slide, what happens is that the other 2 hosts would see, or the auto-healing service would see that something is wrong with one of the hosts, and would essentially grow a new host, which is essentially a new digital copy of another server that we add on the fly, and would regrow the missing virtual partitions on this particular server and would heal it automatically, or would cause for a full failover. So in a sense, the auto-healing is done automatically. There's nothing for the end users or our end users to do. We are doing it behind the scenes automatically for them. But if they really want to read more about it, then we have a bunch of materials on our web that show how we pull the trick of this super highly available service that, again, has been running in a telco environment very successfully. You wouldn't imagine picking up the phone and not getting a dial tone. So in a sense, we're pushing into the cloud a super highly available telco solution, which does provide for a super highly available environment. So if I'm trying to kind of put it all together, so we're seeing a service that is MySQL for all intended purposes on the front end, because we have not changed the front end. It remains MySQL. It brings in the best of both worlds because it's like a NoSQL capable, super robust, distributed, scalable solution underneath the hood in terms of the storage engine. And it provides for the great requirement that people expect from the cloud, which would be the scalability and high availability of it. So this puts it all together, and moving us into slide number 14 that talks about what are the versions that we're going to the market with. And there are 3 versions that actually we are re-announcing, an older one and 2 new ones in February. And the first and foremost one is the Xeround free, and there's no string to chat and no catch and no 6-point font sketches anywhere hidden in the fine print. This is a totally free database that you can use. The only limitation is it's limited in 10 megabytes, but you can use it as long as you wish. We've consulted with some of the platform as a service guys and some of the large clouds, and all of them offer free service for 30 days with databases ranging from 5 to 10, where we took the higher end of that, the higher set of 10 megabytes, and decided to offer it completely free for as long as you wish. So that's the free tier that would be used mostly for small web apps, development, staging, and so on. Then we are going to market with a new tier that was not available before, which is what we call the Xeround Basic, that has 2 flavors to it. 0 to 100 megabytes would start at $17 a month, and then the 100 to 250 megabytes would cost $33. And the reason we're going to market with this particular offering is because this is a tiered offering. We went to market initially with a pay-per-use model, and what we've found and heard from our users is that in some cases they would prefer a tiered offering where they would know exactly how much they're going to be paying at the invoice at the end of the month. It would not get surprised by usage, traffic, transactions, connections, and so on and so forth, like it's been the case with Amazon and others, where they thought they were paying one and they actually billed for another thing, which either they weren't aware of or did not really realize. So they prefer a fixed tier. and this is where they want to go. And then we're sticking with what we had before, which is the Xeround Pro, which is the ultimate telco grade solution that's been built for the cloud, and it's currently serving our higher end customers with larger databases and super high availability and elasticity capabilities. And this services that we offer SLA. And I think that for now we're the only vendor that provides phone support for online databases. I'm not aware of anybody else that provides phone support, free phone support for the database. Last slide, number 15. So we're currently running in Amazon in the US as in Europe. We're running on Rackspace in the US, soon to be coming in Europe as well. We're running on Heroku platform as a service, coming soon, Cloud Control, which is a Heroku-like European provider. And there's a bunch of other clouds and platform as a service vendors coming soon. We have 3 more clouds coming in this year and 4 additional platforms coming in this year. So I think that by the end of this year, wherever you would go, you would essentially hit on Surround, whether directly with our brand on top of it, or you would be able to tell it it's powered by Surround through a branded solution, or would even not know that you're running on Surround because it would be part of somebody else's service. So this is where I hand it over to the mob to find out what are the questions and issues that they can answer.
Okay, well, thanks for that, Razi. Question about the migration process. Is it really disruptive if say I was somebody who was not running in a cloud environment today? How much work is it to turn over the workload over to you guys and have it run in this elastic cloud?
Okay, so first and foremost, using our service, migrating to our service is as easy as changing one line of code, which is the connection string. Now the question becomes, how are you migrating to our service? Are you migrating from another cloud service or a hosted internet service, or are you considering altogether to move from a local hardware-based solution on your current private data center and moving into the cloud? So I think that the major and most important consideration would be to run the database and application in a single location. So whoever that's considering running in the cloud needs to assume that everything needs to be run in the cloud. When I say cloud, it could be a hosted mode for that matter. Anybody that wants to run in a shared environment, in a public environment, needs to assume that they cannot run the application in one place and the database in another place. Now the question becomes, migration-wise, and that's actually the only thing, is how do I move my data? So assuming that you are using MySQL and you're moving to our service, which is MySQL, essentially it's about dumping the data from your database and importing the data on our end. And once the data is uploaded, you're up in the air. Or if you need to create new databases or from scratch, then you're literally up in the air with less than a minute. So it's mostly about just moving the data.
And then you mentioned moving one of your clients from Amazon to another cloud solution provider. That just brought the question: how does billing work? Are they being billed by different depending where you happen to be hosting this, or are you guys just doing all the invoicing at one-stop shop?
So if you get the service from us, everything is one-stop shop. You get everything from us, including the billing. So this means that if you're running on Amazon, you get billed on the Amazon rate. If you run on Rackspace, you get billed the Rackspace rate. And that's for the very straight, simple reason, because we rely on whatever the cloud provides us in terms of virtual machines and technology. If they provide it, we use it. If they don't, we bring our own. So typically, for instance, the rates on Rackspace would be higher than the rates on Amazon. So naturally, the service on Rackspace would be more expensive than the service on Amazon. So if you want to move your service from Amazon to Rackspace, you need to realize you would be paying more, or vice versa. In other cases, like in Heroku, where our database is part of the add-on program, then actually they get billed completely by Heroku, but we get our share from Heroku. So this is a very typical add-on program where the vendors share revenues from the actual end customer. So depending who's the front, who's in the lead for the service. So in Heroku, it's Heroku in the lead. In Amazon Rackspace, we're the lead.
And Razi, you've been doing this for a while. What kind of reactions are you getting from customers? Giving them this elasticity and this always-on capability. I mean, how are they responding?
So we're getting, for the most part, a surprise. great surprise. People are not, they can't really believe that how easy and simplistic is just to join our service and how easy to configure it because, people come in with expectations to be running mem caching and sharding and a bunch of other tools that may be very relevant and valid for other use cases. But in our use case, there's nothing for them to actually, no reason for them to use it or to continue using it or even considering because it's built into our platform. People who have been running on Amazon or other places have been hit by high availability issues or scaling issues because they have expectations of running, of getting in the cloud a super highly available and scalable environment, whereas in fact, the cloud is as far as it gets from being super highly available and scalable environment unless your application and your overall configuration has been built to handle that. So the cloud may be very effective cost-wise, CapEx and OpEx, but it's not the perfect place from a high availability and scalability issue. So most of the users who get to us are extremely surprised by how simple yet highly scalable and available the service is. During the beta, we have here and there some glitches with, service and unclean bugs and so on. We cleaned most of those out of the way as we went to become public, and we continuously improve on the way that we handle the queries, we distributed the queries. One thing to keep in mind is that our database is a distributed database, so we do not use a single storage. So if you're running MySQL to run data warehousing or business intelligence, Xeround is probably not best suited for you because every full table scan would need to bring tables for multiple hosts and locations, which would take forever. So if people come to us and say, I need it for reporting business intelligence or data warehousing, I would tell them, guys, thank you very much. This is not the place to go. Our focal point would be web applications that are characterized mostly with high-end OLTP use cases and need a highly available, scalable endpoint on the database.
Well, terrific. So, Razi, kind of a wrap-up question here. Thinking about quality of service, do you have monitoring tools so that if a provider like Amazon is having hiccups, that you can still provide that solid service, that always-on capability?
Yeah, so we have our own monitoring tools. We do not rely on anybody else's because what we have seen is oftentimes that Amazon monitoring tool will not alert in time on their own hiccups, like you say. For instance, in the last colossal disaster in Ireland, we detected their hiccups earlier than they did, and we moved the live database as they were live and running into another data center while they were running and notified our customers that we moved them before even these customers were alerted that something is going extremely south on the data center. So we rely on our own tools. We have developed our own monitoring tools. We do use some retail tools on top of it just to manage everything, but we are mostly relying on our own tools because we run in multiple data centers. Oftentimes, even if the data centers are not connected in between themselves or lose network connectivity, we can tell the difference between an inside monitoring versus an outside monitoring. So if you use typical tools that would try and ping and see things going from the outside, sometimes they would think the service is not available where it is, or vice versa. They would say that it is available where it is not. So we have learned it the hard way, and we do our own monitoring.
Terrific. Well, Razi, I want to thank you once again for coming on the show today.
Thank you very much. My pleasure, and it's been a great experience for us, and looking forward for additional shows down the road. Thank you very much.
Well, terrific. I look forward to that as well. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of cloud computing.